So, what do we mean when we say something is soluble? What is solubility? Basically, solubility is the amount of a solute that can dissolve in a solvent. Okay, so how much we can put something, think about salt, sugar, how much of that can we put in water until it can no longer dissolve in that water? How soluble is it? And to think about this, we're going to use an analogy. So, in a classroom, we have a certain amount of desks. Our desks are going to be like our solvent. Okay, so maybe we have 28 desks. That means we have room for 28 students, which in this case, in our analogy, will be our solute. So, at most, we can have 28 students. And can we have less than that? Certainly. But can we have more than that? Well, for our analogy, we'll take a look to see. We'll come back to this table here in 1 second once we kind of talk about some of these terms. So, a saturated solution contains the exact amount of solute as a solvent can hold. So, again, 28 desks, we have 28 students. Every available space is being taken up and is being used by the solute, which in this case is the students. There's no more room for it to add more solute in this solution. An unsaturated solution has less than the maximum amount of solute that can be dissolved. So if we have 28 desks still, maybe this time we only have 20 students, right, which is our solute. So the solution can still have or contain more solute if we continue to put more solute into the solution, right? We still have room for 8 more students. A supersaturated solution contains more solute than the solvent can dissolve. So maybe we have 28 desks and we have 32 students, right? Now we have more solute than solvent than we have desks. So what would we see happen? In the analogy, we'd see something maybe standing up or hopefully getting dust from someone else's classroom. But in a solution, we would actually start to see the salt, let's say it's salt, the salt can no longer continue to dissolve in the solution, meaning we'll just see the salt kind of appear as salt. It will just kind of stay in solid form as those salt grain particles, and they would probably just rest on the bottom. So a supersaturated solution, the solute has to go somewhere. It just doesn't dissolve, and we can still it would still be visible to us in the naked eye. And that kind of leads us to our table. So solubility in 100 grams of water at 20 degrees Celsius. So let's say we have an imaginary glass of water. There's 100 grams of water in it. And table salt. So table salt is 36 grams, has a solubility of 36 grams. What does that mean? Well, if we weighed out 36 grams of table salt and we put it in that cup of water, all of it would dissolve. So that basically is 36 grams of table salt can be dissolved. If we had, and that would be a saturated solution, right? 28 desks, 28 students. In this case, we have 36 grams we can put in. We have 36 grams that is saturated. But what if we put 30 grams of table salt in? That would be unsaturated, right? Because we still have more space for salt to dissolve in the water. And conversely, what if we had 40 grams? That would be supersaturated. And that's where we could probably start to see little grains of salt in our glass of water, right? Because some of it, there's no space for it to dissolve, so it's just going to stay kind of clumped together as a solid and fall to the bottom. Different compounds have different solubilities. So table salt is 36 grams. Baking soda is 9.6 grams. So 9.6 grams would be how much we would need to put in to make it a saturated solution. Anything under that, like 6 grams, that would be unsaturated. Anything above that is supersaturated. So part of the assignment for this week is to think of an analogy similar to how we use the student and desks. Don't use the same analogy. You will not receive any points for it. But think of a way that we can define saturated, supersaturated, and unsaturated with an analogy of your own. All right, I will talk to you guys later.